Okay, this video is on active transport and bulk transport. The last video was on passive transport, and so these are the last two types. Now, passive transport was when molecules move from high concentration to low concentration with no energy at all. Active transport is kind of the opposite of that. It requires energy. It's active. So in this case, molecules move from low to high instead of from high to low. Well, in order to do that, it requires energy. It's kind of like a fish swimming upstream against the current. Okay, so it has to fight that current, and then the only way to do that is to use energy. And that energy is in the form of ATP, adenosine triphosphate. For this one, a really good example of active transport is the sodium-potassium pump. The sodium-potassium pump is in our nerve cells. So the only way that our nerves can get all over our body, all the messages that they carry anyway, is by the use of a sodium-potassium pump, which means that the molecules are moving against their gradient in order to help us send the messages to where they need to go. So with active transport, one similarity it has to a type of passive transport is with facilitated diffusion. Active transport requires a protein carrier, but it's different in that it goes against the gradient. Okay, so molecules move from low to high. In this comparison chart, you can see simple diffusion, where molecules are moving from high to low. Here's your kind of key here, high concentration to low concentration. So diffusion, simple diffusion, it goes straight across the cell membrane. These two are showing facilitated transport, facilitated diffusion. Again, moving high to low, but with the use of a carrier protein. And then this one is your active transport. You can see you still need a protein carrier, but this time it's going in the opposite direction. It's going from low to high. So it's going against the gradient, which means it requires energy. All right, so I'm going to show you this picture here. This is supposed to represent the cell membrane. So you have your phosphate heads and your lipid tails. And this is a protein carrier. Up here you see a molecule that would like to go down here to meet up with all of its friends, we'll say. Okay, but it requires energy to do that. So this molecule, where there's just one, needs to go down here where there's a whole bunch. And in order to do that, it needs the protein carrier. So, and you can see it has that special shape, so it will fit with the protein carrier very nicely. But what is required for it to get from here to here? More than just this protein carrier, it's also going to need energy. And that energy is in the form of ATP, which you see right here with this molecule. So this molecule will attach to the protein carrier, drop off its phosphate, and cause it to change shape to allow the molecules to go to the opposite side of the membrane. Again, it uses energy, and it's moving the molecules from low concentration to a high concentration. Okay, so that's pretty simple with active transport.